Hello. Hi, everyone. Thanks for coming. So yes, my name is Juan. This talk is called Building Your Own WAF as a Service and Forgetting Out False Positives. It will also say something around and also forgetting out latency for your customers, but it was getting too long, so it will be covered on the talk. So yeah, this is me. I'm a security lead developer at Booking.com. This talk is about a system that I built at Booking.com to solve a specific set of challenges related to application security. I have a blog post where I wrote about my work, usually in infrastructure or application security, and a Twitter feed. So yeah, so to go on an overview of this talk, I will start by doing an introduction on what a WAF is, how you can deploy such a product, then a bit of what WAF as a service is, what I mean by that, on how we can block attacks without false positives or increase latency, and finally, if there's time, a demo. So yeah, WAF. It's a web application firewall, pretty established technology to protect against the layer 7 attacks. They can do many things. So the basic stuff that you might know of XSS, remote code execution, SQL injections. Depending on the WAF product, you might cover other stuff, but mostly focused on the application part. So I will go a bit into how the WAF can be deployed and establish a bit of the problem I was facing. So to give you an overview, a WAF product can be deployed in inline mode, which means that then the WAF is basically between the traffic of the web application and the user. That means that anything that happens, you can actually block any attack that you detect, transparent to a web server. But if you have a huge application deployment with multiple data centers and network topologies that might evolve with your company, this can become very challenging to be able to place them in the correct place. Then you have the out-of-band deployment model, which means that you can no longer block attacks, but it's very simple for you to place a tap on your network, start copying the traffic. But of course, you cannot block them, and perfect for secrecy and other, let's say, different ways of implementing transport security means that it's becoming harder and harder for you to actually be able to inspect the traffic that happens between the web application and the customer. Newer deployment mode has been the agent mode. So this means that you're basically placing something alongside of your web application. In the Kubernetes world, you can imagine a sidecar there. In bare metal, it might be a process running on the same bare metal box. But basically, it's very easy for you to scale it because it scales with your web application. But of course, it's a lot more invasive. And depending on how many resources this agent needs, it can become very inefficient to use it. And of course, the cloud mode, which is like the latest fad. Basically, you're routing your traffic through a cloud provider. They are checking if this is malicious or not. If it's already the cloud where you're deploying your application, that can be great. If not, of course, you have added latency. And in a way, this is outside of your control. You are giving the keys to somebody else to look at the traffic and decide if it's malicious or not. So basically, with what I spoke about, you can see some problems here. Of course, the network placement, the availability, but one of the big ones, not related to deployment mode, it's more about the false positive rate, which can mean that you have analysts trying to tune the application so you are not affecting users when they're not performing attacks. And of course, there's a lack of control of developers, and depending on your organization, they can present a lot of pushback against this. So yeah, how did this talk start? Basically, I was working at Booking.com in a very challenging environment. There was no acceptance for false positives or added latency, which means that we didn't have a WAF, and we need something that would not add any latency to any of the applications and would not block any users at all. And there was a lot of reluctance towards black box solutions. So this was about also how to actually present a solution that the developers might feel comfortable with, the application might block based on this WAF, and also solve these problems of latency and false positives. And this is how I started looking for a middle ground. So I saw the benefit of the out-of-band mode, which means that great, I'm not affecting the application, but I'm not actually blocking the attacks, which was what I wanted. And that's why I started looking for something like this, which is what I call a hybrid WAF service. So in this case, by looking at the context of the attacks, I can realize if it's a real attack or not, and remove the false positives affecting customers. In this way, you are not using an appliance in the network topology. It's more like an API call, so just like a WAF service. And of course, the application can decide how it wants to react. So it gives them a lot of control over this. So some stats on the production implementation here. There's like 10 million requests logged per month, 10,000 distinct attack identifiers. I will go over that afterwards. No latency added, which was like one of the big concerns, that we couldn't be adding latency to regular users. And of course, less than 5 recorded false positives over 2 years. So this talk is not just about this WAF architecture and solution, but also how you can build one. So that's why I'm going to go through a use case of something I already have published in GitHub, so you can actually do it yourself if you want to implement it. And that's why I mentioned that there are already open source components. I'm going to walk through how you can have a log processing pipeline to actually find out about what's going on with your web application, and the WAF service and how to interact with it. It might be a library or an agent. So in this case, as I mentioned, this is I'm using Google Cloud and using Flask as the web application, which we want to protect. And the code is, I will share the code afterwards. But basically, we have this web application, we have a customer, and we want to protect against attacks. So this is a high overview of the architecture solution. So that's a diagram where you see the different components and how this web application interacts with the web application firewall service and is able to protect without adding false positives or blocking regular users, and also without adding latency to those users. So let's go each component at a time. So first, the web application. It's going to be able to decide if it wants that something goes in inline mode or an out-of-band mode, which means that when the application actually gets a request, there's going to happen this decision. Is this actually malicious and I want the WAF service to interact with this, or I want this to happen in an out-of-band mode? And one key part here is that we're not just going to create we are going to create a log of the interaction. So if you have seen Nginx logs, you can think about something similar, but with a lot more data that we're going to be able to use. Now, we have the web application here, but we need to interact with the web application firewall service. So there's two options for this. One option might be to deploy an agent, which has some of the issues I mentioned around an agent deployment, but it can have a minimal footprint because we're not doing a lot of logic. It's basically doing an API call, and it can interact with the application to get all the settings that it needs. Or a library, which is what I'm using for this talk. There's an inherent risk with using a library, which means that now if the library, if you're using, let's say, a Django framework, and you are placing a library which is using the same, let's say, libraries to actually do the API calls, if there's a vulnerability with the library itself or the framework itself, it might be too late for the library. So that's something to take into account. It's a lot easier to implement with libraries, this solution, but there's a risk that you have to take into account, at least for the real-time blocking. Now, the WAF service, which is like the key component here, this is what's going to actually get a request and decide, make a prediction about it, which is what most WAFs do. They basically see some traffic and they might make a prediction if this is malicious or not. The interesting part with this is that it's not just one application, as you might get used to, or one product, but it's more of a service which can have multiple plugins in it. So you can imagine it as a sort of API, which is actually mirroring traffic to different components and getting predictions out of them. So some of the applications that might be used as plugins might be, for example, open source ones like Mod Security or Naxi. These are open source applications which are very good at providing the web application firewall capability. But then you might want to also use a commercial product. Here's where it can become very interesting, because I mentioned before the different deployment modes and how when you have a commercial product, it might be hard to place it on the network. In this case, you can just place it as another plugin, and that allows you to make ensemble predictions, or to actually compare two commercial products, or compare your current mod security setup with a commercial product. From this perspective, you don't need to worry so much about network topology. You just need to add it as another plugin for the solution. And custom modules. So here's where you can actually start expanding the WAF service by adding things like, in this case, I added a rate limiting and rule engine plugin for the public code in GitHub. But you can do much more, like business logic related to your application yourself, or machine learning models. In this one in particular, I'm actually borrowing this from Joao Olaya, who is a data scientist which works with one of my teams. And we had the situation of the WAF service using mod security for most of the predictions. But when using one of the settings of mod security, which is called Paranoia 2, we were finding a lot of false positives. Now, the false positives can be fixed from the perspective of how can I say it? From the perspective of mod security itself. And I will explain later why the false positives were not so much of an issue of affecting customers, but more an issue about precision. So we were looking at this lack of precision and decided that we could tune it from the mod security part, or we could take advantage of the custom information we have on our organization. And then he built a model, which is an LSTM neural network, to be able to get a string, which will be an input. So, for example, this message, select all from tables, and the model will actually create it into features and make a prediction. So it really looks like an SQL injection. So this is not the replacement of mod security. This was actually something aiding mod security. Since we can actually have as many plugins as we want, we can actually say things like, if mod security and this model agree on a paranoia level 2 rule, then we think this is malicious. So this is just an example of how you can extend the capabilities. And that's basically what this is, right? It's an API which can have a lot of plugins behind the scenes and make a prediction on that. So that's the extensible part of the WAF as a service. So to continue on the high-level overview, you then need to be able to process out of band. So that means that we are not adding latency to a customer itself. The request just went to our application, and then it was sent through a queue in the form of a log. For that, in this particular case, I'm using Google Dataflow, but you can use pretty much any component that provides the same capabilities. It's going to be able to replay the requests here against the WAF, but which were not replayed through the web application. And it's also going to calculate scores in windows of time. So how many times I have seen this in a period of time. Then you have a component which is the detection component. So this is the one that's actually getting these scores which were calculated. And in particular, I'm using BigQuery to interact with long-term storage. But the point here is that you are not only looking at a particular moment or a particular context of 30 seconds. You can take advantage of all the data your application has to consider more things, which I will go over in detail later. And the state store is the component which is actually storing all the information that the library or agent are going to use to decide how they interact with the WAF service. And finally, for this, I added a visualization component, in this case, Elasticsearch. So pretty much it's easy to do it for this open source version. If you want to, and you have your own SIEM, then you can use your own SIEM. It's basically where all the information of the out-of-band and inline activity is stored. And then you can have information on the attacks. So for example, in this case, most of the requests are going on a request level, which means inline on my test. And there I can visualize things like, okay, we have 3 plugins. One of them decides it's an attack. 2 of them are saying it's not an attack, but we are still deciding it's an attack based on the logic that we have. So for now, I covered pretty much the high-level overview and how you can have multiple capabilities on the same product. But one of the key things is how do we block attacks? And also, we don't want to block regular customers. So the way that we can do this is by doing traffic routing. So we are not doing inline, we're not doing out of band, we're trying to do something in the middle. So this is what I call fingerprint-based routing. So it basically decides based on the storage that some particular, either a particular, let's say 0-day string or a particular user ID or a combination of user agent and IP address is behaving in a malicious way, and then decides to actually route the traffic to the WAF. And this can be manually or automatically added. Then you have network-based routing. So you can think of this as we decide that particular sets of network ranges, like proxies or Tor exit nodes, are actually malicious. And from this perspective, we are not saying that it's malicious. You're basically saying that I'm willing to add latency or possible false positives to these exit nodes because the risk that I have from them is a lot higher, and the business value that they are giving is a lot lower to actually justify it. If, for example, 80% of your attacks come from a particular country, which is not your main customer, you can make these decisions. In a way, this is all about risk acceptance. And the interesting part here is that it's not about the product itself. It's about the application. So each application, each endpoint itself, so each /login can have its own logic of how they want to make these decisions. And of course, virtual patching. So in the same way, you can say a particular endpoint, which a particular parameter is something that we know has a vulnerability. We want to only route that traffic through the WAF inline, and the rest we want to continue deciding if we think it's an attack, then do the routing. Now, the part of how do we actually not have false positives. That's the key part, and the thing that actually made my life so difficult, because it's there are a lot of great commercial products, but the biggest problem was we couldn't have people tuning them all day, and we couldn't be affecting our users. So one of the best things is that this, as I mentioned, is per application, which means that we can have different logics for each of them, and even the application owners can make a decision around this. And for that, I want to make a key distinction between two things. One thing is detection false positive, or I call it detection false positive. That's what would happen here, and that's what I was mentioning before around, for example, mod security paranoia 2, having false positives for some applications. That's not actually affecting customers, that's not adding latency, that's just, in a way, noise. And noise means that you actually take longer to make a decision if something is malicious or not. And blocking false positive, which is what I'm actually really interested in, is how many of the users are actually being blocked when they are not performing an attack. And that's the thing I'm optimizing for. So some of the key parts to do this is to consider business logic. So since this is a product that we have, and in our case in particular, it's pretty much custom built using a lot of great tools like mod security, we have a lot of flexibility to use information that we have on our application, like the key business activity, the history of the particular identifier we're looking at, and what would be the impact of blocking them. Then the historical analysis is quite similar, but you can take into account more things. Like in this particular endpoint, which is your chat endpoint where people are sending messages, maybe the probability of a false positive for SQL injection is a lot higher. So instead of going and trying to tune it in a ridiculous way, you can actually say, okay, my score is going to be, or the probability of this being malicious is going to take that into account. So you're also taking into account the previous activity of the detection of false positives. And the context analysis. This is kind of the closer in time, which is in the last 30 seconds, in the last minute, how many requests have I thought are malicious coming from this user ID, this IP, or this particular fingerprint I am finding? Depending on that, is that you can then decide, actually, this is malicious, and all the information I mentioned before. And the key part here is that you are delaying a bit the decision on routing inline the traffic, but that's what's actually decreasing a lot the probability of this becoming a false positive, a blocking false positive. And this is an example of what I mean by that. So let's say that we have on the chat endpoint a message that says, I will sleep for 1 or 2 days. If you have a regex, which is actually looking for sleep, it's going to think this an attack. Now, SQL injections, in particular blind SQL injections, need a lot of requests to be able to actually find a vulnerability. So if you look at the probability, and we say we have a very bad rule, so 1 out of 1,000 requests is going to be incorrectly considered a false positive. But we want to get to this number, so 0.0001%. Given that most of these detection false positives are independent from each other, that means that the probability of getting to 5 of them consecutively happening gets pretty much to that probability. So you are delaying a bit the decision, but in the particular case of attacks that need volume, this is pretty much always the case. Anybody who's running any kind of a tool to find SQL injections will not do 2 SQL injections. And these are the factors that can influence the scoring. So you got the type of vulnerability. So different types of vulnerabilities like remote code execution, SQL injection, XSS have different probabilities of creating a false positive. Then the rule. So one regex can work worse than a different regex. And of course the source, because it's not the same getting it on the payload than getting it on the cookie. The probability of the rule triggering a false positive for that type of vulnerability can change drastically based on that. And this is all information that you already have because you're already collecting this all as part of the out-of-band mode. So this is something else that Joel Aya, the data scientist at Booking, worked on. So in this particular case, it's quite small, but the idea is that it's checking for different periods of time. So for 1 minute, for 5 minutes, in different thresholds, which you can imagine it as scores. What is the amount of false positives, so actual attacks which are not marked? What is the amount of customers which will be affected? And what's the precision? So basically, of all the attacks we know that actually happened, how many of them we are actually detecting? So in our case, if we're looking to get to a 0 false positive probability, then we actually are looking to the ones that have 0% of customers affected, but the highest number of malicious requests blocked. And that's how you can either do this analysis by hand, or you can actually have this analysis happen automatically by adjusting the thresholds. So this is pretty much the hybrid mode. In a way, this has the benefits of not adding the latency to the good visitors, since every time there's a request, it actually checks, is this a request which I think is malicious? And in those cases, that's not going to add the latency if it's not malicious. Then you have the flexibility and extensibility, which is great, because that also means that you don't have to start thinking about having several different security components. You could embed your bot detection solution with your red limiter, with your normal WAF component, and get all these benefits. So in some cases, you might want to actually have it write it for everything, but depending on the application, it might change. And the concern of the locking false positive, actually, that should not be detections. So you don't care, well, actually, that's the point. This is remove your concerns of the detection of false positives, because you really don't care that much if you, on the out-of-band process, you are detecting things which are malicious, or the out-of-band process things are malicious. What you care about is what are you actually moving from the out-of-band to the inline, and what's actually blocking there. And in the out-of-band, these detection false positives are now noise. So that noise is not going to change anything. Worst case is only delaying the decision. And of course, one of the big caveats is the time. So now if you can imagine of 0 day, you have one remote code execution, you execute it once, and there was never any malicious traffic going on from here. Nobody ever knew about this 0 day. In a way, that means that you also don't have it as a rule in the WAF, but that also means that it's going inline mode. You might find out about it on the out-of-band mode, but it might be too late already because you're not routing that traffic. So if, for example, you have, let's say, an endpoint or an application which has very high risk data, like transactional data, you might say, actually, I want this always inline. I don't care about adding latency. I don't care about affecting our customers. But if you are dealing with most of our applications where the risk appetite might be higher, then you can actually say, okay, I will have a different score, which might not be able to block every single request on the first time, but then will not allow more than 3 requests to happen with these malicious requests. And of course, increase complexity. Depending on what's your current setup, this could actually reduce your complexity if you have a huge network topology and you're dealing with multiple data centers. But if you are dealing with a cloud WAF already, then in that case, you might have a bigger complexity. In some cases, for example, with AWS WAF, you could actually pull this off by just creating a reverse proxy to the cloud WAF and then using the normal login operations of the WAF for your application for the out-of-band mode. But of course, it's more complex than just having a black box which starts blocking whatever it sees. So yeah, now I will attempt to do a demo. So for this, I have a Kubernetes cluster running. So for example, here you can see that there's the WAF service. Then there's state store. You have ELK, and there's a demo website, which I want to protect with this WAF service. So if we go to that website, actually we'll just open here. This is a normal website, it's working. Now, in particular, I have the website configured in identifier mode, which means that at the request stage, so when the request comes in, it's actually checking if there's any identifier on the state store that it needs to route inline. In the response stage, when the request comes out, this is disabled, and then I saw also the WAF proxy routing. So in this particular case, there's one local IP because I have a scanner which is constantly scanning to make sure that things are working, but my IP is not there, which means that if I execute an SQL injection, nothing should happen, or at least it should allow it. Now, if I execute several of them, what should happen is that now the request itself should have gone through the out-of-band mode. And if I check the configuration, give it a bit of time. Oh, I know what's going on. I think I had the alloc placed. Yes. So let's do it then. I had alloc. Okay. It was not the lock, it was just taking time. So basically what happened right now is that this request was blocked, but this one is not blocked. And I don't know if you noticed, but there's a bit of delay now when I do this. The delay is actually the extra call to the WAF service, which is going on behind the scenes. And in the same way, if we wanted to say something like, okay, let's actually have it enabled in full mode. So for example, we do something like this. And show the configuration. We still see this is my IP address, which was detected at 2835. But we remove that IP address. That should mean that this is still blocked. And this is also still taking time because I have said actually inline, it should be full mode. So every single request goes in the inline mode. And the visualization that comes out of the box with this, which is basically a Terraform script, which builds this, is Elasticsearch. And here you can see, for example, my IP address is being detected by this particular mod security rule. And if I check them, I should see that mod security, this particular rule, it thinks it's normal. Okay, so this is not normal. Let's look for something which is attack. Here. So it detects an SQL injection. And then what happened was that there were 3 plugins running. So mod security thought it was an attack. Rate limiter is not think it's an attack. The rule engine does not think it's an attack. So in the same way, I mentioned that you can have several plugins. So I could just say this particular IP address, I want to add it as an identifier to be blocked. So we just say this one, and we just create this rule, which sets this particular IP address to be blocked, which means that now, no matter what kind of request I do, mod security thought it was not an attack, but a different plugin, which was the rule engine, thought it was an attack. So this is just a very simple example of how this can be extended. So this could be also something which is checking if it's a bot, or this is a different product you have for fraud from that perspective. And finally, you can also do the virtual patching, which means that if we do something like this, and let's say that you know that this particular ping endpoint has a vulnerability, so this one, you could actually configure and say that you want to add the virtual patching for that particular endpoint. And that basically means that any request that goes to that particular endpoint is not going to check if this is malicious or not. So let me delete the identifiers again. So this is basically cleaning the cache, so that now if we check the configuration, we have this block rule. Actually, I need to remove the block rule then. Well, I can actually leave the VPN for a second. Should be safe, this Wi-Fi, I hope. So now I should have a different IP address, which means that if I do a request here with an SQL injection, this is still blocked. Wait, no. Check. It got disconnected. Well, yeah. So this is pretty much how it works. I will not play my fate more with the demo. But it's in GitHub. So what I did basically, like 10 hours ago or yesterday, I just ran a Terraform script. That was pretty much it. Everything's working out of the box. You can then connect and do whatever you want. So just to go over what we just saw, so just to make sure it's very clear, what happened was the first request that goes to a web application, here. It's actually, there's a cache check. So it's not on that request, but there's a cache check going on, which is able to decide, actually, this IP address, for example, or this user ID is not malicious. We don't have it on our state. Then that sends that particular request by encapsulating it. So you can imagine that you're serializing the request, the headers, the payload, enough for you to be able to replay as close as possible to the original request information through a channel like a PubSub. Then there's a data flow component, which is looking at these requests and sending an API call to the WAF service. The exact same API call that you might have from the web application when it's in inline mode is happening on the out-of-band mode. So it's evaluating, is this an attack or not? Based on that, it's getting a prediction and doing some score calculation, like how many have I seen for this application in this period of time for these different fingerprints. Then the detection component is the one that can get with historical data from BigQuery and say, okay, this particular fingerprint of user ID, in this period of time, I have not seen anything, let's say, too good about it, so we should treat it as a normal fingerprint. Then I will also check on the context of how long it has been for this particular endpoint and take into account the false positive rate. And what happens is that might decide in the detection mode, okay, this particular fingerprint, let's upload it to the cache, which means that every 100 milliseconds or every second, the web application is refreshing that cache internally. And then for the next request that happens, or the 7th request, or as many are as needed for the out-of-band mode to think this is malicious, then the web application gets that request and performs it, getting the cache update, performs the inline behavior, because now it considers that this particular fingerprint is inline. And what this basically accomplishes is that you actually have the two modes going at the same time. You have most of your traffic in an out-of-band mode, but some parts of the traffic, which are considered malicious, are routed in an inline mode. And depending on your risk appetite, that percentage can change. And what your precision is might be lower, and you might accept more false positives. But this does allow you to get to the false positive rate to pretty much 0. And the biggest reason for you to then have blocking false positives is now the thresholds that you decide. Because in a way, this allows you to even consider, if I have a bug on mod security, or I have a bad regex, or somebody deploys a new application, what's the score that should be there so I will actually affect the customer? And we have found out that that score actually can still be high enough for you to add so much friction and so many problems to attackers that they cannot actually discover any vulnerability. And at the same time, even if there's a bug on the application that actually makes a cookie look like an SQL injection, that still is not going to affect the regular customers, which are not doing like 100 requests per minute, depending on your application. So yeah, as a summary, what I mentioned was that you can use the hybrid mode to add the latency to malicious actors, stopping the false positives. And this is key. You can actually do it per application and per endpoint. So all these scoring calculations can depend on how these endpoints react to different plugins that you have for the WAF. And the flexibility, things like adding a machine learning model or adding your own custom rules, even if you're using a commercial product. So you can have the best WAF commercial product and still say, okay, actually, I want to also use these other things to expand the capabilities or to improve the context awareness of that product. So yeah, you can try it. It's here in GitHub. just doing this command line, if you just execute this, it should actually create some uses which are needed, set up the start the Terraform project, and I think it might also start a reverse proxy for the Kibana, but that's pretty much it. And you can follow me on Twitter to send me any questions or messages, and let me know if you have any questions. Thank you.
Any question?
Yes.
Great. Oh, great. Works. Just wondering, how do you actually detect false positives? You say you don't care. Generally, I, as an engineer, will not care as long as users are somehow happy. But you say 5 false positives in 2 years. How do you know you're not missing a lot of them? That anyway, it's like it's a website. It's more or less free. So if one of my requests fails, I hit refresh, and I don't care. But how did you actually made a lot of effort to quantify this, or it's like, okay, it seems to work, so we're fine, and we don't really care?
Yeah, that's a good point, because, for example, what we have is that there's when this is blocked, there's a main list that tells you send a report here. But of course, many people might not do it. So in practice, if in 2 years it was lower than the thousands or tens of thousands, I think this would be awesome compared to our alternative. But it's a good point. I would love if, I think that we are trying to get better at that, because we have the thing of sending the email, but then people might not send the email, so maybe you can work with the UX on that. But it's a good point. But for sure, what I can tell you is that if you have a tool which is creating detection of false positives, this will dramatically reduce the blocking false positives. Because one simple way of actually evaluating this is that you can actually see every single thing that you actually put on the inline mode. So if you can just do a quick look and sample the ones that go inline, which should not, even with huge traffic, it should not be that many, because you're actually pointing to the ones that are actually creating a lot of malicious requests. If you find one which is a false positive, that's already a big deal, right? But that's the two things. One, getting the feedback from the users or customers, and the other one is by looking at the things that you actually say should be routed inline. Yes. Other questions?
I have one.
Yes.
Since you are using GCE product, did you compare it to Cloud Armor?
No.
I've seen that they have kind of WAF now. It used to be a DDoS, and now they have a WAF module apparently.
Now, I would like to check it out. What I'm most interested would be on if they actually take into account context, because that's the big thing, at least. And I only know of one product that does that, which I think it's called Signal Sciences. So they actually take into account context, but I'm not sure of any other product. And that's the problem. If it's something that doesn't take into account context, you're basically saying that as soon as you have any kind of attack-looking part on your request, that's going to start affecting the customers. So, but yeah, it would be nice to compare. I didn't.
And I have another one. I don't remember the exact output of your comment, but is it good practice to run every component in the same pod?
It's not in the same pod. It's actually the same cluster. So it's actually one container per pod. So when I did kubectl get pods, it gets you all the different pods in the same cluster. Oh, but are you actually asking about the WAF service itself?
No, the demo you made.
Oh yeah, so what I showed was actually one cluster, I think 7 different pods. But if you go into the detail of the WAF service itself, it might make a lot of sense to say the WAF service is running every single of the plugins as a different sidecar in the same pod, because that's a lot more efficient from that perspective. And I think it follows the design pattern from Kubernetes. I don't remember the name exactly for that, but that would make sense. And in practice, I think I'm actually running mod security in the same container of the same pod, not as a different container, but just because I was lazy to add it as a different container. In practice, you would want to have it as a different container, and then you can evaluate them inside the same pod. Sorry. Any other questions? Cool. Well, thank you very much, everyone, for attending. And if you have any questions, send me a message or talk to me. Thanks.